Hi everyone, we're discussing cervical vertebrae, and I'm referring to this book called BD Chaurasia, which is a very popular anatomy book. So I'll be reading the lines and explaining them here. Starting off, cervical vertebrae, the identification. They're identified by the presence of foramina transversalia. So transverse foramen, its Latin name is foramina transversalia. There are seven cervical vertebrae, out of which third, fourth, fifth, and sixth. These are typical vertebrae, whereas 1, 2, and 7 they're atypical vertebrae. The body is small and broader from side to side. So if you're referring to the body, small, it's very small, and then it's broader from side to side compared to front backwards. The other thing is its superior surface is concave transversely. So this is the superior surface. It's concave and it has upward projecting lips on each side. The interior border of the surface may be beveled, it may be leveled off, the interior border. The inferior surface is saddle shaped, it looks like a saddle, being convex from side to side and concave from before backwards. So it's concave from before backwards and convex from side to side. Now, the lateral borders are beveled and form synovial joints with the projecting lips of the next lower vertebrae. So it's like side borders, you can say, the lateral borders, they're beveled and they can form synovial joints with the projecting lips of the next lower vertebrae. The anterior border projects downward and may hide the intervertebral um, disc, the anterior border. So this is the anterior border, it projects downward. The anterior and posterior surfaces resemble those of the other vertebrae. Now, vertebral foramen. This is the vertebral foramen. It is larger than the body. It is triangular in shape and it can be larger than the body because it is triangular in shape because the pedicles are directed backwards and laterally. So where is the pedicle? This is the pedicle. This is the pedicle. This is the lamina. That's the lamina. So they're saying the pedicle, it's directed backwards and laterally. So therefore, it forms a triangular shape. What's the function of pedicle? Pedicle basically joins the body to the transverse process, right, and the vertebral arch. Now, continuing further, we have this line here that says that vertebral arch. Now, the pedicles are directed backwards and laterally. Pedicles, as I've already told you, backward and laterally. The superior and inferior vertebral notches are of equal size. What are superior and inferior vertebral notches? So, if you look at a vertebrae from side, right, you'll see that there'll be sort of uh, well, this is a transverse spine, but I'm finding an accurate, image to show you. Yeah, so this is the vertebral notch. This is the vertebral notch. So they're saying that the vertebral notches, they are um, of equal size. The superior and inferior vertebral notches are equal size in the cervical vertebrae, right? The lamina are relatively long and narrow, being thinner above than below. So lamina, they're long and narrow. The superior and inferior articular processes for articular pillars which project laterally at the junction of pedicle and the lamina. Now they're saying that the superior and inferior articular processes, these, they form articular pillars which project laterally at the junction of pedicle and lamina. So very important. These articular processes are present at the junction of pedicle and lamina. The superior articular facets are flat and they are directed backwards and upwards. So this is the inferior one, this is the superior one. So superior, this is the back portion, this is the anterior portion, this is the anterior portion, and this is the back portion. Transfer the spinous process, it points to the back. So they're saying that the superior articular process and facet, it is flat and it is directed backwards and upwards, right? Inferior articular facets are also flat, but they're directed forwards and downwards. This is a forward position. Now, the transverse process are pierced by foramina transversalia. Each process has anterior and posterior roots which end in tubercles joined by the costotransverse bar. The costal element is present by the anterior root and anterior tubercle. Where's the anterior root and anterior tubercle? So normally, let me just open this image. Yep. Here you can see this is the anterior tubercle. This is the anterior arch, right? And rest of them will explain in a second. Moving on, they're saying that the interior tubercle of the sixth cervical vertebrae is large and is called the carotid tubercle. Very important. So, sixth cervical vertebrae, its anterior tubercle, they're saying it's large. So here you can see the carotid tubercle of Cassignac. So they're saying this is the anterior tubercle of six cervical vertebrae. It's large, and it is a common site where the common carotid, it's a common site where a common carotid artery can be pressed against. So common carotid artery is often pressed against this. The spine is short and bifid or bifid. The notch is filled up by the ligamentum nuchae. Now the spinous process of these cervical vertebrae, they're short and they're bifid, they're split. And the notch is filled up with the ligamentum nuchae. Ligamentum nuchae, very important, we'll discuss again in the attachments and relations. Now let's talk about the attachments and the relations. The anterior and posterior longitudinal ligaments are attached to the upper and lower borders of the body in front and behind respectively. So let's find out where anterior and posterior longitudinal ligaments are. This is the posterior longitudinal ligament and this is the anterior longitudinal ligament. They're attached to the upper and lower borders of the bodies in front and behind. So if there's a body in front, uh, body is there basically. So anteriorly, it's anterior longitudinal ligament. Posteriorly, there is a posterior longitudinal ligament. And then you have on each side of the anterior longitudinal ligament, the cervical part of the longest colli is attached. So on each side of the anterior longitudinal ligament, you'll find a muscle which is the longest colli. Posterior surface has two, and the posterior attached to the anterior surface, and then the posterior surface of the same ligament, there you'll find that there are basically two or more foramina for the passage of basivertebral veins, right? So anteriorly longicolli muscle, there on each side, and posteriorly there are two or more foramina through which you'll have basically basivertebral veins going through. Now they're saying that upper borders and lower borders of anterior surfaces of the laminae provide attachment to the ligamenta flavi or ligamenta flava. So this is the laminae they're saying. So laminae is the plural for lamina. Okay? So we're saying that lamina, the interior surface of it or upper border of it, you can say upper and lower border of it, it provides attachment for the ligamenta flava. Now where is ligamenta flava here? Right here. So see, ligamenta flava, and this is the arch. So if you talk about the arch, you know there is lamina bound to be here. Now, the foramen transversarium transmits the vertebral artery, the vertebral veins, and the sympathetic trunk. Right? I've already told you this in the previous video. So more, let's elaborate the sympathetic trunk. A branch from the inferior cervical ganglion. So vertebral artery, vertebral vein, and a branch from the inferior cervical ganglion. Now the anterior tubercle gives origin to the scalenus muscle, longest capitis, and oblique part of the longest colli. The anterior tubercle, that's what we're talking about right now. So this gives attachment to a lot of muscles, the three muscles: scalenus, anterior, longest capitis, oblique part of the longest colli. Now the costotransverse bars are grooved by the anterior primary rami of the corresponding cervical nerves. Then the posterior tubercle also gives origin to a lot of muscles, which includes scalenus medius, scalenus posterior, then levator scapulae, splenius cervicis, longimus cervicis, and iliocostalis cervicis. Then the spine gives origin to the deep muscles of the back, which is the which is the spine. Here you cannot see it, but yeah, it's there. And actually, the in the atlas and the axis, you do not have the body and the spinous process. So this is the spinous process. This gives origin to deep muscles of the back, including interspinales, semispinalis, thoraces, and cervicis, spinalis, cervicis, and multifidus. Now, talking about the secondary centers, two for the annular epiphyseal disc for the peripheral parts of the upper and lower surfaces of the body. So you have basically secondary centers present, and there are two for the tips of the transverse processes and two for the bifid spinous process. These basically appear during puberty and fuse with the rest of the vertebrae by 25 years. Now talking about, so this was the basic information. Now talking about the first cervical vertebrae, it is called atlas. Here you can see, this is atlas. Um, It can be identified by the following features. It is ring shaped. It has neither body nor a spine. Now, atlas has a short interior arch, a long posterior arch. So this is the interior arch, which is short, and the long posterior arch. I have mentioned that. Other than that, um, they're saying that it has right and left lateral masses. So these are lateral masses. You can see lateral masses on the these articular surfaces. So these are superior articular surfaces, and just there you'll have the lateral mass. And transverse processes. Obviously, it also has the transverse processes. Now, the posterior arch is there an anterior arch. Anterior arch is short, posterior arch is long. Now, anterior arch is marked by the median anterior tubercle on its interior aspect. Its posterior surface, right at the posterior surface of it, there is an oval facet which articulates with the dens. Right, so this is the anterior tubercle. Right behind that, there's an articular facet for dens. Posterior arch, it forms. This is a posterior arch. It forms about 2/5 of the ring. Now, its posterior surface is marked by a median. So this is the front, right? Anterior. So this is the posterior. Its posterior surface is marked by a posterior tubercle, median posterior tubercle. The upper surface of the arch is marked behind the lateral mass by a groove. So the upper surface of the posterior arch is marked behind the lateral mass by a groove. This groove is present for the vertebral artery. Now, each lateral mass shows the following important features. So these are the lateral. This is the lateral mass, right? Its upper surface bears the superior articular facet. This facet is elongated forwards and medially, concave, and is directly upwards and medially. It articulates with a corresponding condyle to form atlanto-occipital joint. So very important. The superior articular surface it forms, it articulates with the occipital condyle. Atlanto-occipital joint is formed. Hence, the lower surface is marked by inferior articular facet. This facet is nearly circular, more or less flat, and is directed downwards and medially and backwards. It articulates with the corresponding facet on the axis vertebrae to form atlanto-axial joint. So very important. Superior articular facet forms atlanto-occipital joint, and inferior articular facet forms atlanto-axial joint. The medial surface of the lateral mass is marked by a small roughened tubercle, which I cannot really identify here for now. I don't think so. You can see it. Then they're saying that the transverse process projects laterally from the lateral mass. Yes, it is unusually long and can be felt on the surface of the neck between the angle of the mandible and the mastoid process if you know feel or palpate deep enough. Its long length allows it to. So the long length of the transverse process, it allows it to act as an effective lever for the rotatory movement of the head. The transverse process is pierced by foramen transversalium. What are the attachments in a relations? The anterior tubercle, it provides attachment to the anterior longitudinal ligament. And previously, I also told you that if there's a body present, right, vertebral body's interior part, anterior surface, its upper and lower borders, they're going to give attachment to anterior longitudinal ligament, and the posterior surface, upper and lower borders will give attachment to the posterior longitudinal ligament. Other than that, I also told you that the anterior longitudinal ligament, if it's there, right? So on each side, it will give attachment to the longest colli muscle, right? It's this is its anterior side. And anterior longitudinal muscles, posterior surface, there are two or more foramina, and through this foramina uh, is possible the passage of basivertebral veins. Now moving on, they're saying yes, that anterior longitudinal ligament, it provides insertion on each side to the upper oblique part of the longest colli muscle. Uh, Let me make this clear. So tubercle, you have the attachment of anterior longitudinal ligament, right? And if there's a body, so that body will give the attachment to the anterior longitudinal ligament. Now, the insertion, this muscle allows insertion of longest colli, basically.